Hello everyone, welcome for this lecture. Today we are going to discuss the reciprocity theorem. Let's see the statement of this. It states that on any linear bilateral single source network, then the ratio of excitation to the response remains the same when the position of the excitation and responses are interchanged. Here excitation means voltage, response means current. Okay, so in the circuit V and I ratio remains the same if you change to the to its positions V to I and I to V. Okay, let's see, there is a note we have to be remember. In order to apply reciprocity theorem, the circuit must have a single source. Initial conditions are assumed to be absent and dependent sources are excluded, and when the position of the source and responses are interchanged, their directions should be same as in the original circuit. Okay, let's see the proof for this. Consider a single source network. Okay, consider this network which is shown below. So here we have a single source which is a voltage source, and response we have taken as a Ix here. So we have to take a ratio of this V and Ix when this is in this position. It should be remains the same, and when you have interchanged V to I and I to V, that is this circuit will becomes voltage has to be source or excitation has to be replaced by the response, and this response has to be replaced by your voltage source. Then your circuit will consist of, when you have interchanged, that time this voltage should have your Ix, that is a response, and this voltage source is going to shift at response side. Okay, so this will be your voltage source, right? This at that time also we have to get V by Ix ratio should be same. Okay, let's prove this. Consider this network. You have two ways to solve Ix. Our intention is to get Ix. Then once we have got that V by Ix, you can take a ratio. So you can apply KVL, means you can apply KVL for this first loop, second loop, apply KVL for the both the loops and solve for the equation. That is also holds good. Or you can directly go for Ohm's law also. That is Ohm's law and your branch current formula. That is, to find out this Ix will be your branch current. Okay, so to find out this branch current, what you have to do, main current you have to calculate, main current into resistance of the other branch, okay, divided by total resistance, that is R2 and R3, R2 plus R3. Here we have to calculate first what is the main current. So to do so, first we have to calculate that what is the I. I is nothing but in the circuit voltage divided by equivalent resistance. Okay, we have to calculate what is the equivalent resistance. To do so, that we have to calculate by R equivalent equal to, observe your R1 resistance is there and how R2 and R3 are connected. Here R2 and R3 are in parallel. So take a parallel combination of R2 and R3, and that combination will be in series with your R1. That is your equivalent resistance. So this you can write. Therefore I will be equal to, substitute R equivalent value here. So V divided by R1 plus R2, R3 divided by R2 plus R3. Here only you can simplify this, else you can simplify later. We'll try to solve here only. V divided by, so take this LCM here also. Okay, so make a LCM of this. It is R2 plus R3. Okay, R1 into R2 plus R3. Okay, plus R2 R3. Okay, and now this R2 plus R3 can come up. You can take V into R2 plus R3. Okay, divided by, expand this, R1 R2 plus R1 R3 plus your R2 R3. Okay, so this formula is your I. Okay, substitute that one in the branch current formula. As we know, Ix is the branch current. Apply the formula, main current into resistance of the other branch divided by total resistance. Substitute that calculated value of I. Okay, and then simplify it. Okay, you have simplified it already. V into R2 plus R3 divided by R1 R2 plus R1 R3 plus R2 R3 into R2. This is into R2 divided by R2 plus R3 as it is. Okay. So here you can cancel these two. Okay. You can cancel these two, and remaining terms are V into R2 divided by R1 R2 plus R1 R3 plus R2 R3 denominator. Okay. Now let's take the ratio of excitation to the response, that is V by Ix. Ratio is nothing but V by Ix when you are taking. So this goes up and this comes down, that is R1 R2 plus R1 R3 plus R2 R3 divided by R2. So let's say this equation number as 1. Okay. So now let's interchange position of your excitation and responses. So when you have interchanges, you get response here. Instead of Iy, you can take Ix also, or you can simply mention it as Iy. To defer that, you have interchanged the place of both. Okay. So let's take it as a Iy, and the source is here. Okay. This is our original network. Okay. So current was flowing through the resistance. So here also we have shown, and the voltage source we have replaced. And now same procedure we have to apply. We have to calculate the current. Okay. So to calculate Iy, again we have two ways to apply KVL, or you can go by branch current formula. So to do so, what we can do is I equal to V by R equivalent. So here R equivalent you can get, what we can say R equivalent is, so we have to go through like this, then R3 resistance. Okay, this resistance will be in series with this combination, that is R1 parallel with R2 combination. Okay, simplify that, you can place like this. Okay, here also you can simplify it, that is take a LCM of these two factors, that is R3 into R1 plus R3, okay, plus R1 R2 divided by R1 plus R3. Okay, let's substitute this one in equation. I is equal to V by R equivalent. So I is equal to V divided by R3 plus R1 R2 divided by R1 plus R2. Let's simplify this equation. Okay, V divided by, we have taken LCM in the denominator, and then we have multiplied R3 into R1 plus R2. Okay, so simplify this. So this R1 R2 will comes here in the numerator. So this is your I. Now this I we have to substitute in branch current formula, that is, so let's take Iy, that was a branch current. Let's take I is equal to, okay, Iy is equal to I into, okay, Iy equal to Iy is equal to branch current is equal to main current into resistance of the other branch divided by total resistance, that is R1 plus R2. Okay, same thing we are going to place here. Okay, so now in the place of I, we are going to substitute whatever we have calculated, and R2 as it is, and then R1 plus R2 as it is. Okay, so now this is also in the denominator, and this is also in the denominator. Make a single denominator, and then here R1 plus R2 and R1 plus R2 is going to get cancelled. Now Iy is equal to V into R2 divided by this. Now take the ratio of this. You can get V by Iy will be equal to this, R1 R3 plus R2 R3 plus R1 R2 divided by R2. Let's call this equation number 2. Just observe your first equation and second equation. First equation and second equation. Okay, so these two are same. Okay, from equation 1 and 2, we can say that by interchanging the excitation and responses, the ratio of it remains same. Okay, hence the proof of this reciprocity theorem. Okay, let's take an example for this, a simple examples. So for the network shown below, find current Ix, apply reciprocity theorem, and show that ratio of the source to response remains same by interchanging them. Let's say excitation is 6 volt and response is Ix here. Okay, so let's find out. First what we have to do is, let's find out the Ix. As we have told, we have two ways to do it. Either you can do it by KVL or you can go by method of Ohm's law and branch current formula. Okay, so we'll go along with the KVL. Let's apply KVL for this loop and let's apply KVL for this loop. This I'll take I1 and we'll take I2. So here I2 is nothing but your Ix. Okay, let's find out both the apply KVL for both the loops. Let's take a first loop. Direct equations we can write 2 ohm plus 6 ohm. Therefore 6 I1 minus 4 current flowing through this 4 ohm is not only I1, here I2 is also flowing. So it is 4 I2 equal to 6 volts. Okay, let's call this equation number 1. Okay, so and second equation is minus 4 I1 plus 8 plus 4 is 12, I2 equal to 0. These two are your equations. You can solve I1 and I2. For this you will get I1 and I2. So here once you get a I2 value is nothing but your Ix. Okay, let's see. Or you can go by your Ohm's law as we have explained. For that too, if you would like to do through that, what we can do is let's calculate I. I is nothing but V divided by R equivalent. Let's calculate R equivalent. That is 8 and 4 ohms are in parallel along with 2 ohm in series. So 2 plus 8 parallel with 4. So this combination you have to do 2 plus 8 into 4 divided by 8 plus 4. That also you can do. So we have done with the equivalent values. So take I is equal to V by R equivalent. So voltage was 6 volts divided by R equivalent is 2 plus 8 parallel with 4 ohm. So calculate that value and substitute here 6 by 4.667. I equal to 1.285 ampere. Okay, check with KVL also. Okay, so this is your main current. Now we have to calculate about Ix. Ix will be equal to main current, okay, into resistance of the other branch, which is 4 ohm, divided by total resistance, it is 8 plus 4. So substitute the values. I is 1.285. Okay, so I is 1.285 into resistance of the other branch is 4 divided by total is 8 plus 4, which is 12. Okay, simplifying this you get Ix is equal to 0.428 amperes. Okay, let's interchange the source and responses. Okay, when you changed source and responses, voltage source was here and now it is here, response was here and now it is here. So you can change the name or keep as it is. So this is Ix and this is a V. Here only we can take V by Ix in the first case, which is V divided by Ix. V was 6 volts divided by Ix was 0.428. Okay, this is the ratio of it. Okay, so now we'll calculate what is the Ix in the second case, that is when we have interchanged the source and responses. Let's take the same formula. I is equal to V by R equivalent. Now R equivalent we have to do, but this one through when we have a source here, that time R equivalent will be equal to 8 plus, okay, 8 plus these two resistances are in parallel, that is 2 parallel with 4 ohm. Okay, simplify this as I told you. So once we have calculated, let's take its ratio of it. It is 6 by 0.428. So once you have calculated R equivalent, that is 8 plus 2 and 4 are in parallel. So it comes 9.33. Okay, I equal to V divided by R equivalent. V you know that is 6 volts divided by 9.33 ohms. Get the current, that is 0.6428 ampere, which is main current. Let's calculate the branch current. Ix is equal to main current into resistance of the other branch divided by total resistance, which is main current is 0.4648 into 4 divided by 2 plus 4, which is 6. So Ix is equal to 0.4285 amperes. Now you can calculate the ratio of it, which is V divided by Ix, 6 divided by 0.428. Earlier also it was 6 divided by 0.428 ratio, and this one is also 6 divided by 0.428. Okay, therefore the reciprocity theorems holds good on this. Okay, and we'll see the next numerical, that is, in a single source network shown below, find Vx and verify reciprocity theorem. Okay, they have given a circuit diagram like this. Observe, here they have mentioned phi at an angle 90 amperes. Okay, current is flowing through this. It doesn't mean that here there is a open circuit. Okay, this they have mentioned phi at an angle 90, meaning of this one is there is a current source here. Okay, which is phi at an angle 90 ampere. Okay, and then we have a 5 ohm, 2j ohm, 2 ohm, and capacitor here, it is minus 2j ohm. Okay, and then we have to calculate Vx through reciprocity theorem, and we have to verify it. Okay, so and to calculate Vx, what we can do is, so Vx is nothing but, in the entire circuit, here is our current source, this is nothing but phi at an angle 90. Vx we have to calculate. Vx is nothing but voltage across this capacitor. Voltage across this capacitor. So what is the voltage across this capacitor? Is nothing but current flowing through that capacitor and impedance of that capacitor, which is 2j ohm. Okay, let's see. This circuit can be represented like this. Phi at an angle 90 ampere, current is flowing, means we have to take it as a source. So now I we know, that is phi at an angle 90, but we don't know Vx. First we have to find out the Vx, afterwards we have to take Vx by I. Okay, in both the cases. Okay, let's see how we can find out. So same thing here, this is the Vx. Vx is nothing but voltage across minus 2j. Okay, voltage across minus 2j ohm. Okay, is nothing but current flowing through that minus 2j ohm and into impedance of that. Okay, for that let's apply KVL. Okay, so first loop, and you can take a second loop. So we have mentioned here it as a Ix. So here you can remember, you can take it as a I2, and this is a I1. I1 and I2. I1 is nothing but phi at an angle 90, because independent current source is there, so no need of applying any law for that, KVL. So directly you can take phi at an angle 90 ampere, and here I2 is nothing but your Ix, and Ix is that current is nothing but which is flowing through your capacitor. Okay, Ix is flowing through this capacitor as well. Okay, so Ix is nothing but current flowing through this minus 2j ohm. That we have to calculate. Let's apply KVL for both the loops. Okay, I1 is phi at an angle 90. Let's apply KVL for the second loop. So shall we move from this? It is 2. Okay, 2 ohm resistance is there, and then next minus 2j. Okay, minus 2j ohm. I2 come to this plus phi plus 2j. Okay, we can take a combined phi plus 2j. Its impedance is nothing but I2 minus I1. Okay, I2 minus I1. Okay, equal to 0. So apply, that is simplify that. Simplify this, apply KVL. Directly you can write. Okay, so directly I mean to say 2 minus 2j I2, okay, plus here 5 plus 2j I2 minus I1, okay, equal to 0. Simplify this term. I1 we can place first, that is minus 5 plus 2j I1, okay, plus write 2 minus 2j, 2 minus 2j plus 5 plus 2j I2 equal to 0. So simplify this. 2 minus 2j plus 2j get cancelled. So therefore, this simplified equation will be minus 5 plus 2j of I1, okay, plus 7 I2 equal to 0. Okay, after simplifying this, you get this equation. So 7 I2 equal to, so here I1 is there, that I1 value we know, that is phi at an angle 90 degree. So substitute here and send this minus sign to equal side. Okay, then 7 I2 will be equal to 5 plus 2j into phi at an angle 90. Then you can calculate I2, which is equal to 5 plus 2j, phi at an angle 90 divided by 7. Calculate this I2. It is 3.846 at an angle 111.8 amperes. So I2, once you have got, it is nothing but your Ix. Okay. So this is nothing but current flowing through that 2j ohm. Okay. Ix into minus 2j, because we require Vx. So substitute calculated value and multiply with the minus 2j impedance, then you get a Vx. Vx is a 7.69 at an angle 21.8 volts. Remember one thing. So Vx is the variable for us. Vx should be remains the same once we interchange it, because the ratio remains the same as we know it, right? Vx by I will be what? 7.69 at an angle 21.8, and I was phi at an angle 90. So its ratio becomes 1.538. Okay, need not go for completely. You can, if you got Vx, if you are interchanged both source and your responses, Vx also if you are getting the same, then ratio remains same. Okay, next let's interchange the place of source and the response. That is Vx was here, so that is going to be here. Okay, in the place of a response, and this is a phi at an angle 90, so here it comes at Vx side. Okay, so this is nothing but a voltage source over here. Okay, and then now what we can do is, what is the Vx when you have interchanged? This time Vx is not voltage across this, now Vx is here, so this is a voltage across this entire term. That is Vx will be voltage across 5 plus 2j ohm. Okay, voltage will be, Vx will be voltage across 5 plus 2j ohm, which is nothing but current flowing through that into impedance of that. Okay, let's calculate current flowing through this impedance. For that, apply KVL again. Let's take this one as a first loop, I1. Okay, let's take this as a I1 and take a I2. Okay, no need of applying KVL for the first loop. Directly we can write I1 is equal to phi at an angle 90 degree. To find out the I2, what we can do is, we can apply KVL for that. So to apply KVL for that, so simplify this, write it. So we'll start with the 2 ohm, 2 plus 5 plus 2j minus 2j I2, okay, and minus of, because this one loop is there, loop current, so minus of minus 2j I1 you can write, which is equal to 0. Okay, I hope you have got this equation, right? Or else simply we can write in this loop, in this particular loop, there are 4 parameters, 2 resistances and 2 reactances. To get that, it is a 7, okay, plus 2j minus 2j are going to get cancelled. So 7 I2 is there, okay, 7 I2 is there, and in the first loop, in this you have a minus 2j, which is common for both, so it should be minus of minus 2j I1, which is equal to 0. So we know I1 value, substitute that I1 value. Okay, before that send this minus sign to equal side, so it is 7 I2 equal to minus 2j I1. Okay, next you know I1 value, substitute it, and I2 you will get 1.428 amperes. And the next we have to get what is the Vx. I2 is nothing but your current flowing through that impedance. Okay, current flowing through this impedance. Okay, so you have got I2 you multiply with this impedance, that is 5 plus 2J, you will get a Vx. Vx is equal to current through this and impedance. Current is 1.428 into impedance is 5 plus 2J. So multiply this, you get Vx is equal to 7.693 at an angle 21.8 volts, which is same as that of your Vx in the first case, 7.69 at an angle 21.8. Okay, this is also same, 7.69 at an angle 21.8 volts. Okay, therefore you can take the ratio of this one. Okay, see other numerical. Find current through ammeter and hence verify reciprocity theorem. Okay, we are supposed to find out the current flowing through this ammeter and they have given its internal resistance as 1 ohm. So what we can do is, so this network we have to find out voltage we have, that is a 50 volt, and this is the response what we have to calculate. Let's take its direction as Ix. Let's see if there is it in this direction or in the opposite direction. Okay, what we can do is, there are 3 loops, apply. So this is a first loop, second loop, and this is the third loop. Remember, this ammeter it can be replaced by your internal resistance. Okay, so you can replace like this. Then apply KVL for each loop. Let's say first loop, second loop, and this is the third loop. Okay, and then we have to calculate Ix. So here we can calculate it by taking a point P and apply KCL at that point. Here I2 will be entering and I1 will be leaving and Ix will be entering. Okay, so now we will apply KVL for the first loop, second loop, and a third loop. Now we will see, apply first loop, KVL for the first loop. Start from this, directly we can write the equation. You are in the first loop. In first loop, how many resistances are there? 5 ohm, 1 ohm, and a 10 ohm. Total it is 16 I1, and 1 ohm is between I1 and I2, so it is minus 1 I2, and then 10 ohm is minus 10 ohm, 10 I3. Okay, equal to 0. Next, second loop, directly we are going to write the KVL, that is minus 1 I1 because it is at I1 side, and this 20 ohm is between I2 and I3. Okay, so now in the second loop, equation for this is minus 1 I1 plus 26 I2 minus 20 I3. I have explained you how to take this equation directly, okay, in the previous class. So for the third loop we will apply KVL. So in the third loop you observe 10 ohm is between I1 and I3 and 20 ohm is between I2 and I3. So therefore it is minus 10 I1 minus 20 I2 plus 30 I3 equal to 50 volt. Okay. Now solve these 3 equations, first equation, second equation, and third equation by the calci. These 3 are a DC circuit, directly you can solve. After that you will get I1, I2 and I3. I1 as 4.59 amperes, I2 is 5.4 amperes, I3 is 6.8 amperes. Now we will apply KCL at that point P. We will take a point P and let's apply KCL at a point P. So I2 is entering, I1 is leaving, and Ix is entering. So I1 is leaving, so it is I1 minus I1, I2 is entering, so plus I2, Ix is also entering, plus Ix equal to 0. Then simplify this, we need Ix, so therefore Ix will be equal to, you can send these to this side, that is I1 minus I2. You know I1 and I2, you have calculated, substitute those two values and get the answer for that. It is I1 minus I2 is nothing but minus 0.81 ampere. Minus sign we have got because we have assumed its direction as downward. So actually its direction should be upward. Okay. So here we can write a comment that, so this negative sign indicates the direction what we have assumed is opposite to that. Therefore, Ix will be equal to plus 0.81 ampere. And make sure that the direction of current should be in this. Okay. Now, we'll interchange the, we can take a ratio of it. V by Ix, V was 50 volts divided by 0.81, which is 61.72. So, therefore, let's interchange the position of sources and responses. Here, voltage source was here, that has to be put here. Okay. And the direction we have taken as it is, a current direction. Okay. Minus and plus. And here the current direction, so this resistance is replaced here. And voltage source direction. So in the same way we have taken as I3. Now we have to proceed with the same procedure. Here we have three loops. First, second and third. Only difference is here we have 1 ohm. Remember, if you are getting confused with this, you can replace with a resistance with a 1 ohm. And here we have a voltage source. Apply KVL for the first, second and third loop. Okay. Now we'll apply first loop. KVL is, so write it directly, that is 15 I1 minus 10, it is I3. Okay. Minus 10 I3 equal to, plus sign you are reaching, so it should be equal to minus 50. Let's call this equation number 1. Second equation. Let's start moving from this voltage source. We will reach minus 50 plus we will reach here 5 I2. Next plus 20. You are in the second loop. I2 minus I3 equal to 0. Simplify this equation. You will get 25 I2 minus 20 I3 equal to 50. Okay. Like this we have written directly those equation. Third loop, apply KVL for the third loop. You get, that is minus 10 I1. Okay. Or else we'll write systematically. So we'll start from this, that is 10. You are in the third loops, therefore I3 minus I1 plus 20 I3 minus I2 plus 1 ohm resistance. Therefore it is 1 into I3 equal to 0. Simplify this, you get minus 10 I1 minus 20 I2 plus 31. 10 plus 20 plus 1 is 31. I3 equal to 0. Solve these three equations. Here you can observe, first equation is a 15 I1 minus 10 I3 equal to minus 50. And second equation is 25 I2 minus 20 I3 equal to 50. Third loop is minus 10 I1 minus 20 I2 plus 31 I3 equal to 0. Now solve these three equations. We get I1, I2, I3. I1 is minus 2.8, I2 is 2.645, I3 is 0.808. Okay. So you can take Ix is nothing but, you can observe here, Ix is nothing but here, this response. Ix is nothing but the I3 current. So I3 current is 0.808. So Ix, therefore Ix is 0.808 amperes. Then you can take a ratio, V by Ix. V is 50 divided by 0.808 equal to 61.8. Almost same as you have taken a ratio of this. You can take compare with only Ix in the first case as well as in the second case. Ix in the first case was Ix is equal to 0.81 ampere, and it should be same in the second case also. Here we have got 0.808 amperes. Okay, it's approximately you can take 0.81 amperes. Okay.